Welcome to the Huberman Lab podcast, where we discuss science and science-based tools for everyday life. I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. Today, my guest is Dr. David Sinclair, professor of genetics at Harvard Medical School and co-director of the Paul F. Glenn Center for the Biology of Aging. Dr. Sinclair's work is focused on why we age and how to slow or reverse the effects of aging by focusing on the cellular and molecular pathways that exist in all cells of the body and that progress those cells over time from young cells to old cells. By elucidating the biology of cellular maturation and aging, Dr. Sinclair's group has figured out intervention points by which any of us, indeed all of us, can slow or reverse the effects of aging. What is unique about his work is that it focuses on behavioral interventions, nutritional interventions, as well as supplementation and prescription drug interventions that can help us all age more slowly and reverse the effects of aging in all tissues of the body. Dr. Sinclair holds a unique and revolutionary view of the aging process, which is that aging is not the normal and natural consequence that we all will suffer, but rather that aging is a disease that can be slowed or halted. Dr. Sinclair continually publishes original research articles in the most prestigious and competitive scientific journals. In addition to that, he's published a popular book that was a New York Times bestseller. The title of that book is Lifespan: Why We Age and Why We Don't Have to. He is also very active in public-facing efforts to educate people on the biology of aging and slowing the aging process. Dr. Sinclair and I share a mutual interest and excitement in public education about science. And so I'm thrilled to share with you that we've partnered, and Dr. David Sinclair is going to be launching the Lifespan podcast, which is all about the biology of aging and tools to intervene in the aging process. That podcast will launch Wednesday, January 5th. You can find it at the link in the show notes to this episode today. As well, you can subscribe to that podcast on YouTube, Apple, or Spotify, or anywhere that you get your podcasts. Again, the Lifespan podcast featuring Dr. David Sinclair begins Wednesday, January 5th, 2022. Be sure to check it out. You're going to learn a tremendous amount of information, and you're going to learn both the mechanistic science behind aging, the mechanistic science behind reversing the aging process, and practical tools that you can apply in your everyday life. In today's episode, Dr. Sinclair and I talk about the biology of aging and tools to intervene in that process. And so you might view today's episode as a primer for the Lifespan podcast, because we delve deep into the behavioral tools, nutritional aspects, supplementation aspects of the biology of aging. We also talk about David's important discoveries of the sirtuins, particular molecular components that influence what is called the epigenome. And if you don't know what the epigenome is, you will soon learn in today's episode. Coming away from today's episode, you will have in-depth knowledge about the biology of aging at the cellular, molecular, and what we call the circuit level, meaning how the different organs and tissues of the bodies age independently and how they influence the aging of each other. Today's episode gets into discussion about many aspects of aging and tools to combat aging that have not been discussed on any other podcast or in the book Lifespan. Before we begin, I'd like to emphasize that this podcast is separate from my teaching and research roles at Stanford. It is, however, part of my desire and effort to bring zero cost to consumer information about science and science-related tools to the general public. In keeping with that theme, I'd like to thank the sponsors of today's podcast. Our first sponsor is Roka. Roka makes eyeglasses and sunglasses that are of the absolute highest quality. I've spent a lifetime working on the visual system, and I can tell you that the visual system has to contend with a number of different challenges, such as when you move from a bright area outside to an area where there are shadows, you have to adjust a number of things in your visual system so that you can still see things clearly. One problem with a lot of eyeglasses and sunglasses is they don't take that biological feature into account, and you have to take off your glasses and put them back on depending on how bright or dim a given environment is. With Roka eyeglasses and sunglasses, you always see things with the utmost clarity. In addition, they're very lightweight, and they won't slip off your face. In fact, they were designed to be worn while biking or running and in various activities, but they also have a terrific aesthetic, so you could wear them to dinner or work. I wear readers at night and when I drive, and I wear the sunglasses for most of the day. If you'd like to try Roka sunglasses or eyeglasses, you can go to roka.com, that's ROKA.com, and enter the code Huberman to save 20% off your first order. Again, that's Roka, ROKA.com, and enter the code Huberman at checkout. Today's episode is also brought to us by Inside Tracker. Inside Tracker is a personalized nutrition platform that analyzes data from your blood and DNA to help you better understand your body and help you reach your health goals. I've long been a believer in getting regular blood work done for the simple reason that many of the factors that impact your immediate and long-term health can only be assessed from a quality blood test. And now, with the advent of modern DNA tests, you can also get a clear picture of what your biological age is and compare that to your chronological age. And obviously, your biological age is the important one because it predicts how long you will live, and it's the one that you can control. The great thing about Inside Tracker is that compared to a lot of other DNA tests and blood tests out there, is that with Inside Tracker, you don't just get your numbers back of the levels of various hormones, metabolic factors, blood lipids, etc., but it also offers clear directives to lifestyle factors, nutritional factors, and supplementation that you can use in order to get the numbers into the ranges that are best for you and for your health. If you'd like to try Inside Tracker, you can go to insidetracker.com/Huberman to get 25% off any of Inside Tracker's plans. Just use the code Huberman at checkout. Again, that's insidetracker.com/Huberman to get 25% off any of Inside Tracker's plans. Today's episode is also brought to us by Magic Spoon. Magic Spoon is a zero-sugar, grain-free, keto-friendly cereal. Now, I don't follow a strictly ketogenic diet. What works best for me is to eat according to my desire to be alert at certain times of day and to be sleepy at other times of day. So for me, that means fasting until about 11 a.m. or 12 noon most days. And then my lunch is typically a low-carb, keto-ish lunch, maybe a small piece of grass-fed meat, some salad, something of that sort. And then in the afternoon, I might have a snack that's also keto-ish. And then at night is when I eat my carbohydrates, which for me helps me with the transition to sleep and allows me to get great deep sleep. That's what works for me. What that means is that in the afternoon, I'm craving a snack, and the snack for me is Magic Spoon. What I do lately is I put in some Bulgarian yogurt. Sometimes I just eat it straight. Each serving of Magic Spoon has 0 grams of sugar, 13 to 14 grams of protein, and only 4 grams of carbohydrates in each serving. So it really matches that low-carb, keto-ish approach. There's only 140 calories per serving, and they have a variety of flavors: cocoa, fruity, peanut butter, frosted. I particularly like frosted because it tastes like donuts. I try not to eat donuts, but I do love the frosted. And as I mentioned before, I lately mix it with yogurt, put a little cinnamon on there. I'm getting hungry just talking about it now. If you want to try Magic Spoon, you can go to magicspoon.com/Huberman to grab a variety pack. Use the promo code Huberman at checkout to get $5 off your order. Again, that's magicspoon.com/Huberman and use the code Huberman to get $5 off. And now, my conversation with Dr. David Sinclair. Thank you for coming.
Thanks for having me here. It's good to see you.
This is mate, by the way, that we're toasting at 11 a.m. Unlike other podcasts, I don't drink alcohol, so I'm boring that way. But truly, thanks for being here. I have a ton of questions for you. We go way back in some sense, but that doesn't mean that I don't have many, many questions about aging, longevity, lifespan, actionable protocols to increase how long we live, etc. And I just want to start off with a very simple question that I'm not even sure there's an answer to, but what is the difference between longevity, anti-aging, and aging as a disease? Because I associate you with this statement, aging is a disease.
Right. Well, so longevity is the more academic way we describe what we research. Anti-aging is kind of the same thing, but it's got a bad rap because it's been used by a whole bunch of people that don't know what they're talking about. So I really don't like that term anti-aging. But aging as a disease and longevity are perfectly valid ways to talk about this subject. So let's talk about aging as a disease. When I started my research, disease here at Harvard Medical School, it was considered, if there's something that's wrong with you, and it's a rare thing, has to be less than 50% of the population, that's definitely a disease. And then people work their whole lives to try and cure that condition. And so I looked up what's the definition of aging. And it says, well, it's a deterioration in health and sickness, and you can die from it. Typically you do. So I'm thinking that sounds pretty much like a disease. But the caveat is that if more than half the population gets this condition, aging, it's put in a different bucket, which is, first of all, that's outrageous because it's just a totally arbitrary cutoff. But think about this, that we're ignoring the major cause of all these diseases. Aging is 80 to 90% the cause of heart disease, Alzheimer's. If we didn't get old and our bodies stayed youthful, we would not get those diseases. And actually what we're showing in my lab is if you turn the clock back in tissues, those diseases go away. So aging is the problem. And instead, through most of the last 200 years, we've been sticking Band-Aids on diseases that have already occurred because of aging, and then it's too late. So there are a couple of things. One is we want to slow aging down so we don't get those diseases. And when they do occur, don't just stick a Band-Aid on, reverse the age of the body, and then the diseases will go away.
That clarifies a lot for me. Thank you. Can we point to one specific general phenomenon in the body that underlies aging?
Yeah, well, that's contentious because scientists like to come up with new hypotheses. It's how they build their careers. But fortunately, during the 2000s, we settled on 8 or 9 major causes of aging. We called them hallmarks because causes was a little bit too strong. But these 8 or 9 causes, at least for the first time, allowed us to come around and talk together. We put them on a pizza, so everyone got an equal weighting, equal slices. But before that, by the way, we were trying to kill each other in the field. It was horrible.
Interesting that you guys work on aging and trying to kill each other.
Yeah, isn't it? Well, kill each other's careers. I mean, I like to think I was fairly generous, but I was one of the kids, and the old guard really didn't like the new guard. We just came along in the 1990s and 90s and said, free radicals don't do much. There are actually genes called longevity genes, and that caused a whole ruckus, and there was this competition for what never happened, which was a Nobel Prize for this. And it just led to a lot of competition. I would go to meetings and people would shout at each other and just backstab. It was horrible. But then fortunately in the 2000s, we rallied around this new map of aging with these causes or hallmarks. But I think that there's one slice of the pizza that is way larger than the others. And we can get to that, but that's the information in the cell that we call the epigenome.
Well, tell us a little bit more about the epigenome. Frame it for us, if you will, and then we'll get into ways that one can adjust the epigenome in positive ways.
Yeah. So in science, what I like to do, I'm a reductionist, is to boil it down. And I actually ended up boiling aging down to an equation, which is the loss of information due to entropy. It's a hard thing to overcome the second law of thermodynamics. That's fair. But this equation really represents the fact that I think aging is a loss of information in the same way that when you Xerox something 1,000 times, you'll lose that information, or you try to copy a cassette tape, or even if you send information across the internet, some of it will get lost. That's what I think is aging. And there are 2 types of information in the body. There is the genetic information, which is digital, A, T, C, G, the chemical letters of DNA. But there's this other part of the information in the body that's just as important. It's essential, in fact, and that's the systems that control which genes are switched on and off, in what cell, at what time, in response to what we eat, etc. And it turns out that 80% of our future longevity and health is controlled by this second part, the epigenetic information, the control systems. I liken the DNA to the music that's on a DVD or a compact disc. For the younger people, we used to use these things.
I recall.
Yeah. And then the epigenome is the reader that says, okay, in this cell, we need to play that set of songs. And in this other cell, we have to play a different set of songs. But over time, aging is the equivalent of scratching the CD and the DVD so that you're not playing the right songs. And cells, when they don't hear the right songs, they get messed up and they don't function well. And that is what I'm saying is the main driver of aging. And these other hallmarks are largely manifestations of that process.
Can we go a little deeper into what these scratches are? Is it the way that the DNA are packed into a cell? Is it the way that they're spaced? What are the scratches that you're referring to?
So DNA is 6 foot long. So if you join your chromosomes together, you get about 6 foot per cell. So there's enough to go to the moon and back 8 times in your body. And it has to be wrapped up to exist inside us. But it's not just wrapped up willy-nilly. It's not just a bundle of string. It's wrapped up very carefully in ways that dictates which genes are switched on and off. And when we're developing in the embryo, the cell marks the DNA with chemicals that says, okay, this gene is for a nerve cell. You cell will stay a nerve cell for the next 100 years, if you're lucky. Don't turn into a skin cell. That would be bad. And those chemicals, there are many different types of chemicals, but one's called methylation. Those little methyls will mark which songs get played for the rest of your life. And there are other marks that change daily. But in toto, what we're saying is that the body controls the genome through the ability to mark the DNA and then compact some parts of it, silence those genes, don't read those genes, and open others, keep others open that should stay open. And that pattern of genes that are silent, open, is what dictates the cell's type, the cell's function. And then the scratches are the disruption of that. So genes that were once silent, and you could say it's a gene that is involved in skin, it's starting to come on in the brain, shouldn't be there, but we see this happen. And vice versa, the gene might get shut off over time during aging. Cells over time lose these structures, lose their identity, they forget what they're supposed to do, and we get diseases. We call that aging. And we can measure that. In fact, we can measure it in such a way that we can predict when somebody's going to die based on the changes in those chemicals.
Are these changes the same sorts of changes that underlie the outward body surface manifestations of aging that most of us are familiar with? Graying of the hair, wrinkling of the skin, drooping of the face. Walking around New York lately, it's amazing to me. There are certain people that seem to walk looking down at the sidewalk because their spine is essentially in a C shape, right? A hallmark, if you will, of aging that most of us are familiar with. Are these same sorts of DNA scratches associated with that? Or are we talking about people that are potentially are going to look older but simply live longer?
Well, it's actually, you are as old as you look, if you want to generalize. So let's start with centenarian families. These are families that tend to live over 100. When they're 70, they still look 50 or less. So it is a good indicator. It's not perfect because you can, like me, grow up in Australia and accelerate the aging of your skin. But in general, how you look. No one's ever died from gray hair, but overall you can get a sense just from the ability of skin to hold itself up, how thin it is, the number of wrinkles. That is actually, it was a great paper just came out that said that an AI system looking at the face could very accurately predict someone's age.
Very interesting. So I started off in developmental neurobiology. So one of the things that I learned early on that I still believe wholeheartedly is that development doesn't stop at age 12 or 15 or even 25, that your entire life is one long developmental arc. So in thinking about different portions of that developmental arc, the early portion of infancy, and especially puberty, seem like especially rapid stages of aging. And I know we normally look at babies and children and kids in puberty and we think, oh, they're so vital, they're so young. And yet the way you describe these changes in the epigenome and the way you have framed aging as a disease leads me to ask, are periods of immense vitality the same periods when we're aging faster?
Yes. And this is something I've never talked about, at least not publicly. So this is a really good question. So those chemicals we can measure. It's also known as the Horvath clock. It's the biological clock. It's separate from your chronological age. So actually what I didn't mention is that when the AI looked at the faces of those people, they could predict their biological age, their internal age. So your skin represents the age of your organs as well. And the people that look after themselves, we can talk about how to do that later. But there are some people that are 10, 20 years younger than other people biologically. And it turns out if you measure that clock from birth or even before birth, if you look at animals, there's a massive increase in age based on that clock early in life. So you're right. So that's a really important point, that you have accelerated aging during the first few years of life, and then it goes linear towards the rest of your life. But there's another interesting thing you brought up, which is that we're finding that the genes that get messed up, that get scratched, that are leading to aging, are those early developmental genes. They come on late in life and just mess up the system. And they seem to be particularly susceptible to those scratches. So what's causing the scratches? Well, we know of a couple of things in my lab. We figured out one is broken chromosomes, DNA damage, particularly cuts to the DNA breaks. So if you have an X-ray or a cosmic ray, or even if you go out in the sun and you'll get your broken chromosomes, that accelerates the unwinding of those beautiful DNA loops that I mentioned. We can actually do this to a mouse. We can accelerate that process, and we get an old mouse, 50% older, and it has this bent spine, kyphosis, it has gray hair, its organs are old. So we now can control aging in the forwards direction. The other thing that accelerates aging is massive cell damage or stress. So we pinched nerves, and we saw that their aging process was accelerated as well.
Incredible. Yeah, this is more of an anecdotal phenomenon. It is an anecdotal phenomenon, but this experience of in junior high school, going home for a summer, and you come back, and high school in the U.S. usually starts 8th or 9th grade, or grade 8 or grade 9 for your Canadians. And then some of the kids, like they grew beards over the summer, or they completely matured quickly over the summer. Do you think there's any reason to believe that rates of entry into and through puberty can predict overall rates of aging? In other words, if a kid is a slow burner, right? They basically acquire the traits of puberty slowly over many years. Can we make some course prediction that they are going to live a long time versus a kid that goes home for the summer and comes back a completely different organism, or appearing to be a completely different organism? Like they basically age very quickly in the summer. Does that mean they're aging very quickly overall?
Well, yeah, I don't want to scare anybody.
Sure.
That there are studies that show that the slower you take to develop, it also is predictive of having a longer, healthier life. And it may have something to do with growth hormone. We know that growth hormone is pro-aging. Anyone who's taking growth hormone, pay attention. We know
just look at someone who's taking growth hormone.
Yeah.
They often will acquire these characteristics of vitality, like improved smoothness of skin, but,
yeah, sure.
But their whole body shape changes often.
Yeah, I mean, you'll feel better for a short amount of time. You'll build up muscle, you feel great, but it's like burning your candle at both ends. Ultimately, if you want to live longer, you want less of that. And the animals that have been generated and mutants that have low growth hormone, sometimes these are dwarfs, they live the longest by far. A guy in my lab, Michael Bonkowski, he had the longest lived mouse. A mouse typically lives about 2 and a bit years. He had a mouse that lived 5 years, and he gave it caloric restriction, so fasting, combined with one of these dwarf mutations, low growth hormone. I think he called it Yoda. But this is, you look at who lives the longest, it's the really small people. This is a bit anecdotal, but it sounds like it might be true, is that the people who played the Munchkins in The Wizard of Oz, many of them went on to live into their 90s and beyond.
Really?
Yeah.
Huh. Amazing.
And there are some Laurent dwarfs as well. There are dwarf mutations in South America, and they seem to be protected against many of the diseases of aging. You barely ever see heart disease or cancer in these families.
So having owned a very large dog breed, a bulldog mastiff, who lived a long life for a bulldog, 11 years, but there are many dogs that will live 12, 16 years that are smaller dogs. Can we say that there's a direct relationship between body size and longevity, or duration of life?
Well, there is, but that doesn't mean that you're a slave to your early epigenome, nor to your genome. The good news is that the epigenome can change. Those loops and structures can be modified by how you live your life. And so if you're born tall, and I wasn't, and I wished at the time I did grow, but no matter what size you are, you can have a bigger impact on your life than anything your genes give you. 80% is epigenetic, not genetic.
So let's talk about some of the things that people can do. And I've kind of batched these into categories rather than just diving right into actionable protocols. So the first one relates to food, blood sugar, insulin. This is something I hear a lot about, that fasting is good for us, but rarely do I hear why it's good for us. And kind of, one of the reasons I'm excited to talk to you today is because I want to drill into the details of this, because I think understanding the mechanism will allow people to make better choices and not simply to just decide whether or not they're going to fast or not fast, or how long they're going to fast. I think should be dictated by some understanding of the mechanism. So why is it that having elevated blood sugar, glucose, and insulin ages us more quickly? And or why is it that having periods of time each day, or perhaps longer, can extend our lifespan?
Well, let's start with with what I think was a big mistake, was the idea that people should never be hungry. We live in a world now where there's at least 3 meals a day, and then we've got companies selling bars and snacks in between. So the feeling of hunger, some people never experience hunger in their whole lives. It's really, really bad for them. It was based, I believe, on the 20th century view that you don't want to stress out the pancreas, and you try to keep insulin levels pretty steady and not have this fluctuation. What we actually found, my colleagues and I, across this field of longevity, is that when you look at, first of all, animals, whether it's a dog or a mouse or a monkey, the ones that live the longest, by far, 30% longer, and stay healthy, are the ones that don't eat all the time. Actually, it was first discovered back in the early 20th century, but people ignored it. And then it was rediscovered in the 1930s. Clive Mackay did caloric restriction. He put cellulose in the food of rats so they couldn't get as many calories even though they ate. And those rats lived 30% longer. But then it went away. And then it came back in the 2000s in a big way when a couple of things happened. One is that my lab and others showed that there are longevity genes in the body that come on and protect us from aging and disease. The group of genes that I work on are called sirtuins. There's 7 of them. And we showed in 2005 in a science paper that if you have low levels of insulin and another molecule called insulin-like growth factor, those low levels turn on the longevity genes. One of them that's really important is called SIRT1. But by having high levels of insulin all day, being fed means your longevity genes are not switched on. So you're falling apart. Your epigenome, your information that keeps your cells functioning over time just degrades quicker. Your clock is ticking faster by always being fed. Okay. The other thing that I think might be happening by always having food around is that it's not allowing the cell to have periods of rest and reestablish the epigenome. And so it also is accelerating in that direction. There's plenty of other reasons as well that are not as profound, such as having low levels of glucose in your body will trigger your major muscles and your brain to become more sensitive to insulin and suck the glucose out of your bloodstream, which is very good. You don't want to have glucose flowing around too much. And that will ward off type 2 diabetes.
So hunger, of course, is associated with low blood glucose and low insulin. Do you think there's anything about the subjective experience of hunger itself that could be beneficial for longevity?
Yeah, I do. Though you get used to the feeling of not eating. So I'm kind of screwed that way.
It's like cold water. You eventually adapt.
You get used to it, unfortunately. But there are some studies that are being done at the National Institutes of Health that are able to simulate the effect of hunger, but still provide the calories. And it's looking like there's a small component that's due to hunger. But most of it actually is because you've got these periods of not being fed, and then the body turns on these defensive genes. There's a really interesting experiment that was published maybe a couple of years ago by Rafael De Cabo down at the NIH. What he did was he took over 10,000 mice and gave them different combinations of fat, carbohydrate, protein, and he was trying to figure out what was the best combination. And then he also cleverly had two groups, one that was fed all the time or ate as much as they wanted, and the other group was only given food for an hour a day. And it turns out they ate roughly the same amount of calories because, of course, in an hour, they're stuffing their faces. It turns out it didn't matter what diet he gave them. It was only the group that ate within that window that lived longer and dramatically longer. So my conclusion is, and mice are very similar to us metabolically, I think that tells us that it's not as important what you eat, it's when you eat during the day.
What is the protocol that people can extrapolate from that? Or maybe I should just ask you, what is your protocol for when to eat and when to avoid food? Do you fast? Do you ever fast longer than 24 hours? What do you do? And what do you think is a good jumping off place if people want to explore this as a protocol?
Well, if there's one thing I could say, I would say definitely try to skip a meal a day. That's the best thing.
Does it matter which meal, or are they essentially equivalent?
Well, as long as it's at the end or the beginning of the day, because then you add that to the sleep period where you're hopefully not eating.
I think that's an excellent point. I realize it's a simple one, but I think it's an excellent one because I think one of the things that people struggle with the most is knowing when and how to initiate this so-called intermittent fasting. And the middle of the day obviously is not tacked to the sleep cycle in the same way. So it's much harder as well for many people.
Yeah. Well, I'll tell you what I do. I skip breakfast. I have a tiny bit of yogurt or olive oil because the supplements I have need to be dissolved in it. And then I go throughout the whole day, as I'm doing right now here with this glass of water here. I'm just keeping myself filled with liquids, and so I don't feel hungry. Beware that the first 2 to 3 weeks when you try that, you will feel hungry, and you also have a habit of wanting to chew on something. There's a lot of physical parts to it. But try to make it through the first 3 weeks and do without breakfast or do without dinner, and you'll get through it. And I did that for most of my life, actually. Mainly because I wasn't hungry in the morning. Some people are very hungry in the morning, and they may want to consider skipping dinner instead. But I will go throughout the whole day. I don't get the crashes of the high glucose and the low glucose. That anyone who goes, oh man, it's 3 o'clock, I'm going to need to sleep. If you do what I do, you will not experience that anymore. Because what my body does is it regulates blood sugar levels naturally. My liver is putting out glucose when it needs to, and it's very steady and gives me pure focus throughout the day. And I don't even have to think about lunch. I'm just powering through. At dinner, I love food as much as anybody. So I will eat a regular, pretty healthy meal. I'll try to eat mostly vegetables. I can eat some fish, some shrimp. I rarely will eat a steak. In fact, my microbiome is so adapted to my diet. Now, if I eat a steak, it will not get digested very well. I'll feel terrible.
If I don't eat a steak, I feel terrible.
Well,
Argentine lineage, but we can talk about that some other time.
Well, everybody's different. I mean, that's the other thing. What works for me may not be perfect for you, and we do have to measure things to know what's working. I rarely eat dessert. I gave up dessert and sugar when I turned 40. And occasionally I'll steal a bit of dessert because it doesn't hurt if you steal it, right? But other than that, I avoid sugar, which includes simple carbohydrates. Bread, I try to avoid. I've actually noticed, this is just a side note, I used to get buildup of plaque pretty easily. And every time I went to the dentist, they'd have to scrape it off. And I even bought tools to scrape it off because it was driving me nuts. I don't get plaque anymore. And I think it's because of my diet. I don't have those sugars in my mouth that the bacteria feed on and then form the biofilm on the teeth.
Interesting.
Much better breath, by the way.
That's a benefit. So do you ever fast longer than this? It sounds like if you go to bed, you tend to stay up late. I know because I get texts from you at like 2 a.m, my time, which means you're up very late and up early as well. But assuming that people go to sleep sometime around 11:30 or 12, plus or minus an hour, and wake up sometime around 7 a.m. plus or minus 90 minutes, you're eating more or less on it sounds like a 20 hours of fasting, 4 hours of eating, or 16 hours of fasting and 8 hours of food intake, et cetera. But do you ever do longer fasts, like 48 hours or 72 hours or week-long fasts?
Occasionally I do. So my typical day, I would only eat within a 2-hour window. Just usually I'm either eating out or...
So you're 22 too.
Yeah. Yeah, but I love... Well...
And if you exercise, do you feel like then you just power through and maintain that fasted state?
Absolutely. I can exercise, and now my body's so used to it, I don't feel like I need food after exercising. I used to. But have I gone longer? Yes, but not very often. I find it quite difficult to go more than 24 hours. But when I do it, maybe it's once a month, I'll go for 2 days. After 2, and actually even better if you go for 3 days without eating, it kicks in even greater longevity benefits. So there's a system called the autophagy system, which digests old and misfolded proteins in the body. And there's a natural cleansing that happens when you're hungry. Macroautophagy, its name is. But a good friend of mine, Anna Maria Cuervo at Albert Einstein College of Medicine, discovered a deep cleanse called the chaperone-mediated autophagy, which kicks in day 2, day 3, which really gets rid of the deep proteins. And what excites me is she just put out a big paper that said, if you trigger this process in an old mouse, it lives 35% longer.
Wow.
Yeah. So it's a big deal. If I could go longer, I would. But I just find that with my lifestyle, and I'm going always day, 110%, I need to eat at least once a day, unfortunately.
One more practical question, then a mechanistic question related to this. The practical question is, when you are fasting, regardless of how long, I know you're ingesting fluids like water and presumably some caffeine. I heard you had several or more espresso today, which is impressive. But are you also ingesting electrolytes? Like, I know some people get lightheaded, they start to feel shaky when they fast, and that the addition of sodium to their water or potassium, magnesium is something that's becoming a little more in vogue now. Is that something that you do or that you see a need for people to do?
Well, it makes sense, but I haven't had a need to do it. So I don't. I drink tea during the day and coffee when I'm first awake, and I don't get the shakes. So, I don't fix what's not broken. Mm-hmm. And I do add things to my protocol that I think will improve me, and avoid those things, of course, that won't. But because I don't have a need for it, I don't try it. But it does make sense, especially if you've had a big night the night before, you probably want to supplement with that. But I think there's a fair amount of good stuff in tea and coffee as it is.
Okay. So then the mechanistic question is, you've told us that there's ample evidence that keeping your blood sugar low for a period of time, each 24 hours, can help trigger some of these pro-longevity, anti-aging mechanisms, and that extending them out 2 or 3 days can trigger yet additional mechanisms of gobbling up of dead cells and things of that sort. How is it that blood glucose triggers these mechanisms? Because we've said, okay, remove glucose and things get better. You've talked before, maybe we could talk more now about some of the underlying cellular and genetic mechanisms, things like the sirtuins. But how are glucose and the sirtuins actually tethered to one another mechanistically?
Yeah, there's a really good question. That proves you're a scientist, a world-leading one. So what we now know is that these longevity pathways, we call them, these longevity genes talk to each other. And we used to say, oh, my longevity gene's more important than yours. It was ridiculous. Because they're all talking to each other. You pull one lever and the other one moves. And the way to think of it is that there are systems set up to detect what you're eating. So the sirtuins will mainly respond to sugar and insulin. And then there's this other system called mTOR, which is sensing how much protein or amino acids are coming into your body. And they talk to each other. We can pull one and affect the other and vice versa. But together, when you're fasting, you'll get the sirtuin activation, which is good for you. And you'll also, through lack of amino acids, particularly 3 of them, leucine, isoleucine, valine, the body will downregulate mTOR. And it's that up sirtuin, down mTOR that is hugely beneficial and turns on all of the body's defenses, chewing up the old proteins, improving insulin sensitivity, giving us more energy, repairing cells, all of that. And so these 2 pathways, I think, are the most important for longevity.
So interesting. You mentioned leucine. Within the resistance training / bodybuilding / fitness community, leucine gets a lot of attention because there are longstanding debates about how much protein one needs per day and how much one can assimilate at each meal. It makes for many YouTube videos and not much else, frankly. However, it's clear that because of leucine's effects on the mTOR pathway, that there are many people, not just people in these particular fitness communities, that are actively trying to ingest more leucine on a regular basis in order to maximize their wellness and fitness, and in some cases muscle growth, but also just wellness. But what I interpret your last statement to mean is that leucine, because it triggers cellular growth, is actually pro-aging in some sense. Is that right?
Well, it could be. That's what the evidence suggests. And again, it goes back to the debate, should you supplement with growth hormone or testosterone? All of these activities will give you immediate benefits. You'll bulk up more, you'll feel better immediately. But based on the research, it's at the expense of long-term health. So my view of longevity, the way I treat my body is I don't burn both candles. I have one end of the candle lit. I'm very careful. I don't blow on it. But I also do enough exercise that I'm building up my muscle, but I'm not huge. Anyone who's seen me, knows that I'm not a professional bodybuilder. But I tried to actually, here's the key, and I haven't said this publicly that I can remember, I pulse things so that I get periods of fasting, and then I eat. then I take a supplement, then I fast, then I exercise, and I'm taking the supplements and eating in the right timing to allow me to build up muscle sometimes. Because you can't just expect to take something constantly and do something constantly for it to work. And that's why it's taken me about 15 years to develop my protocol. And there's a lot of subtlety to it.
Mm-hmm. Yeah, it sounds like a very rational protocol. Does the name Ori Hofmeckler mean anything to you?
No.
Okay. Just briefly, I discovered Ori Hofmeckler about 15 years ago. He was in Israeli Special Forces. He's now got to be close to 70. Forgive me, Ori, if that number is inflated. He wrote a book called The Warrior Diet, which got very little attention at the time. But what he said was, when he was in Israeli Special Forces, they rarely ate more than once per day, and sometimes once every second or third day. And this is a guy who maintains an incredible physical stature. He's very lean, very strong, and very vital at, I wouldn't say an advanced age, but he's getting up there and he just seems to be getting better and better. Ori Hofmeckler was the person who essentially founded, if you will, although our ancestors founded, to be completely fair, the so-called intermittent fasting diet. He called it the Warrior Diet, and this book didn't get much attention. But one of the things that you just said really reminded me of Ori. I sat down with him. I actually went to his home and sat down with him, and he said, fasting is wonderful, but these pulses where you nourish the body or even slightly overnourish the body, provided they aren't too frequent, have a tremendous effect on vitality. And so I want to use that as kind of a segue to address this issue of vitality versus longevity. Because here you're telling me, and certainly the evidence supports that, growth hormone will make you feel better and younger, taking testosterone or estrogen, we should probably say. There are, women who take hormone therapies later in life who take estrogen, they experience a strong increase in vitality if it's done correctly. But there is an effect of aging the body more rapidly. It's sort of a second puberty, if you will. But this idea of restriction and then pulsing, not necessarily feast and famine, but certainly famine and feast in lowercase letters. There really seems to be something about that. So at a cellular level, like we kind of go back to mTOR and the sirtuins, how do you think that the cells might be reacting to this kind of lowercase feast and uppercase famine type protocol?
Right. Well, the pulsing, I think, is what you want to do is to get the cells to be perceiving adversity. Okay, because our modern life, we're sitting around, we're eating too much, we're not exercising. Our cells respond. They go, hey, everything's cool, no problem. And they become relaxed and they don't turn on their defenses, and we age rapidly. We can see it in the clock. People who exercise and eat less have a slower ticking clock. It's a fact. But my protocol is different than most people's because I am pulsing it. Now, first of all, let's get to why did I even think that might be possible? Because I didn't read the Warrior Diet. What I found in my research was that if we gave resveratrol, this red wine molecule that became well known in the 2000s, if we gave it to mice their whole lifespan, they were protected against a high-fat diet, which we call the Western diet. They had lean organs. They lived slightly longer, but not a lot. And if we gave them a high-fat diet without resveratrol, they actually lived a lot shorter. So resveratrol protected them against the high-fat diet. We gave it to them on a normal diet. They just ate it when they wanted, and there wasn't much effect. This is what's not known, though it's in the supplemental data of the paper that nobody ever reads. The mice that were given resveratrol every second day on a normal diet lived dramatically longer than any other group. So people out there, my critics say, resveratrol didn't extend the lifespan of mice on a normal diet, therefore it's not aging, it's just protecting against a high-fat diet. Well, look at the supplemental data, please. If you give it to the mice every other day, we had mice living over 3 years.
Wow. That's a long time. I have got many, many mice in my ownership in my lab at Stanford, and that's a very long life for a mouse.
It was, by far. And so it was a long lifespan extension. And what that told me is that probably you don't want to be taking a supplement every day. You can take it either every other day or give your body a rest. And I do the same with my meals. I rest during the day, and then I give a nutritious dinner to my body and then give it a rest. Same with exercise. And then I try to time it, because there are times when I'm taking the drug metformin, which mimics low energy. For those of you who don't know, metformin is a drug given to type 2 diabetics to bring down their blood sugar levels. But it's been found that looking at tens of thousands of veterans and others, that those type 2 diabetics live longer than people that don't even get type 2 diabetes. So it's a longevity drug. Right now you have to get it from your doctor in the US. In most other countries, you can just get it over the counter. And you're protected, it looks like, based on epidemiological data, cancer, heart disease, frailty, what else? Dementia. So I take metformin.
In addition, you take metformin and you're fasting each day. So when do you take it relative to the fasting?
Yeah, I always take metformin in the morning, along with the resveratrol, because for a number of reasons, but mainly because my body responds better. And I've been measuring my body for 12, 13 years. But here's the thing. If I'm going to exercise that day, I will skip the metformin. And a lot of people who do pay attention to this kind of thing think that they should stop taking metformin because they're never going to get muscle, or it's going to affect their ability to build up muscle. But that's not true. What metformin does to you, it actually just reduces your ability to have stamina, because it's inhibiting your body's ability to make energy. And so what happens is when you're on metformin, you do fewer reps. But guess what? Those muscles that you do build up on metformin have the same strength and have much lower inflammation and other markers of aging. You just won't have that extra 5% size of muscles. So if you want large muscles, don't take metformin and you'll be fine during your exercise. But for me, I'm not trying to get giant. I want strong muscles and I want to live longer and healthier. So I just try to time it so that I get the most reps out of my exercise regime. But sometimes in scientific literature, it's worth bringing this up. If there's a 5% difference in a graph, then either the press release or some reporter will say, oh my goodness, big difference, 5%, can't take metformin during exercise. That's the headline. And then you go in and it's barely significant, and the graph is distorted because they've changed the axes to make it look bigger. And now it's become a myth that metformin greatly inhibits your ability to exercise, which is not true. But in an abundance of caution, I skip my metformin on days I'm going to exercise. And not only that, I'm one of the 20% of people that has a stomach sensitivity to it. So if I'm not feeling great that day, I don't take it either.
You mentioned metformin is available only by prescription from a doctor, at least in the U.S. Berberine is this substance that comes from tree bark, who I also learned about many years ago from Ori. He said, if ever I'm going to overeat, like a Thanksgiving meal or something, I take berberine. Those were his words. And I tried it. And what's remarkable about berberine is that you can eat enormous quantities of food and not feel as if you've eaten enormous quantities of food. I'm not necessarily recommending people do this. But what I noticed was if I took berberine, which my understanding is it works very similarly to metformin, works on the AMPK pathway, the mTOR pathway, et cetera, that if I didn't ingest food, in particular carbohydrates, I would feel a little dizzy and kind of get a headache, like almost hypoglycemic. What are your thoughts on berberine as an alternative to metformin? And are there any cautionary notes? Obviously people should talk to their doctor before adding or subtracting anything from their life, including breath work or anything that comes up. But with all that set aside, what are your thoughts about berberine and timing of low blood sugar and these sorts of things?
Right. Well, before I had access to metformin, I was taking berberine. It's often known as the poor man's metformin.
He just called me poor.
Women can take it too. So the thing with berberine, and we've studied it in my lab, it is effective at boosting energetics in the body, just like AMPK and metformin does. And we've actually given it to rats and mice and seen that they are very healthy, especially on a high-fat diet. So I think it's likely to be good. There are some human studies that exist, clinical trials showing that it increases insulin sensitivity. You have to take high doses.
Which is a good thing, right?
Yeah.
I think when people hear insulin sensitivity, sometimes people think, oh, well, that's bad, right? No, but you want your cells to be insulin sensitive. You don't want a lot of blood sugar floating around that can't be sequestered into cells.
Exactly. So this is anti-type 2 diabetes. And so this berberine does have wonderful effects on the metabolism of animals, and in some clinical trials on dozens of people it's been tested. Now, there's one cautionary tale which just came up. Matt Kaberlein's lab published that berberine reduced the lifespan of worms. But I'm not sure worms trump human clinical trials at this point. So I would say...
Not in my opinion.
I wouldn't.
But no disrespect to my C. elegans colleagues, or rather my colleagues that work on C. elegans.
Yeah. Well, what I like to do is to give all the information. People can decide what they want. But I would say, if based on the worm data, I wouldn't panic just yet. I think berberine has been shown to be really safe in humans.
You mentioned resveratrol. I think now would be a great time to talk a little bit about protocols for resveratrol, grapeseed extract, et cetera. Let's start with the obvious one that I know you get a lot, but for the record, can't I just drink red wine and get enough resveratrol, David?
You can try. You need to drink about 200 glasses a day. So
I'm sure it's been tried.
There are some. And I drink a glass of red wine a day if I get the chance. But any more than that, it's a lot of calories and your liver will get fatty and it's all bad. So, I mean, realistically, you can only get the 1,000 milligrams that I take a day from a supplement that's pure. Now, there are a lot of people selling resveratrol. If it's not light gray or white in color, throw it away. The brown stuff has gone bad or is contaminated. And the contaminated stuff, beware, it'll cause diarrhea. But regular resveratrol should not do that.
So 1,000 milligrams per day is what you do?
Yeah, and I have for about 15 years now.
And you ingest that with some fatty substance like olive oil or yogurt, is that right?
Yeah, you have to. And other supplements, quercetin, curcumin, these are crunchy things. They're not going to get through your gut. And I'm not just making this up. I always base my statements on human studies. So we've done a lot of studies on resveratrol, as have others since. And we know that we found out early, I was one of the first people to take a high dose resveratrol. And when we included it with food, the levels in my blood went up 5-fold. And so you want to have something in there. If you just drink it with water, it's not going to get through. And unfortunately, some people have done clinical trials without even thinking that they might need to dissolve it in something.
So are you taking this all at once in the morning and chasing it with some olive oil, or are you dissolving it in yogurt? What's the specific protocol?
Yeah, I've been improving, perfecting what I do. For about 10 years, I would take some Greek yogurt, a couple of spoonfuls, put the resveratrol on there, mix it around, make sure it's dissolved, and put that in my mouth and swallow that. These days, what I like to do, because I've realized that olive oil, and particularly oleic acid, one of the monounsaturated fatty acids, is also an activator of the sirtuin defenses. So I'm trying to ingest more of oleic acid. So I switched to olive oil. What I do is I put a couple of teaspoons of olive oil in a glass, mix around the resveratrol and maybe some quercetin, a similar molecule, make sure it's dissolved. I put a little bit of vinegar, and if I have a basil leaf, I'll put that in, and it's like drinking some salad dressing, and it's great.
Delicious. That raises a question that I want to ask before we get to NMN and NR and vitamin B3, which is, by doing that, do you think that it breaks your fast? And I want to just frame this question of breaking the fast in a more general scientific theme, and I'd love your thoughts on this. One of the questions I get asked all the time is, does ingesting blank break the fast? Does eating this or drinking this, coffee, if I walk in the room and someone else is eating a cracker, does it break my fast? People get pretty extreme with this. My sense, and please tell me if I'm wrong, but my sense is that it depends on the context of what you did the night before, whether or not you're diabetic, lots of things. So for instance, if I eat an enormous meal at midnight, go to sleep, wake up at 6 a.m., I could imagine that black coffee or coffee with a little bit of cream might, quote unquote, break my fast. But the body doesn't have a breaking the fast switch. The body only speaks in the language of glucose, AMPK, mTOR, et cetera. So do you worry that ingesting these calories is going to, quote unquote, break your fast? And more generally, how do you think about the issue of whether or not you're fasting enough to get these positive effects? Because not everybody can manage on just water or just tea. Or we should say not everybody is willing to manage on just water or just tea for a certain part of the day.
Well, my first answer is not scientific. It's philosophical. If you don't enjoy life, what's the point? And so I'd like a cup of coffee in the morning, a little bit of milk, spoonful of yogurt's not going to kill me. Olive oil doesn't have protein or carbs in it, not many. And so I'm probably not affecting those longevity pathways negatively. But without that, first of all, I wouldn't enjoy my life as much. Well, the olive oil is not as great as the yogurt, but I'm trying to optimize. And there's no perfect solution to what we're doing. And we're still learning. We don't know what's optimal for me, let alone everybody else. But I'm with you. I don't believe that taking a couple of spoonfuls of something, unless it's high fructose corn syrup, is going to hurt you. Because I've now got the rest of the day till about 8, 9 p.m. of not eating anything. And that, I forgive myself for that. And there's a really good point here. You and I were discussing this earlier. The point about doing this is that you try to do your best. If you go from regular living to don't eat the whole day, you're going to fail. It's like quitting smoking cold turkey. It's easier to chew gum and stick the patch on because your body has to get used to all sorts of habits. And it's social, it's physical, putting stuff in your mouth, chewing, not just the low blood sugar levels. And your brain will fight it. Your limbic system is going to go, hey, do it. And you're going to have to fight it. Once you get through it, you'll be better. But you do it in stages. Do breakfast first, then do a small lunch, and then eventually cut lunch out. Don't go cold turkey because everyone knows it's a fact that if you try to do a strict diet right out of the gates, you'll almost always fail.
No, I think that captures the essence of fasting rationally and a rational approach to supplementation very well. Along the lines of supplementation, what about NMN, NR, and B3 niacin? I want to know what you do. I also want to know what I should do. And I think most people want to know what they should do. I mean, these are molecules that impact the sirtuin pathway, impact the pathways that control aging or rates of aging in the epigenome. How do they do that? And how does one incorporate that into a supplementation protocol, should they choose to do that?
All right. Well, disclaimer is that I don't recommend anything, but I talk about what I do. So a bit of scientific background, these sirtuin genes that we discovered first in yeast cells when I was at MIT, and then in animals as I moved to Harvard in the 2000s. And one of my first postdocs, actually literally my first postdoc, Chaim Cohen, published a great paper just a couple of months ago and found that turning on the sirtuin 6 gene, remember the 7, number 6 gene is very potent. It extended the lifespan dramatically of mice that he engineered, both males and females, which is great. So what you want to do is naturally boost the activity of these sirtuins. They are genes, but they also make proteins. That's what genes typically make, or encode. And then those proteins take care of the body in many different ways, as we've discussed. So how do you turn on these genes and make the proteins they make even more active? You want to rev up that system. So exercise will do it. Fasting will do it. What about supplementation? Well, the first activator of the sirtuins that we discovered that acts on the enzyme to make it do a better job of cleaning up the body and protecting was resveratrol. We looked at thousands of different molecules, eventually tens of thousands. And the one that was the best was resveratrol in the dish. And then we gave it to little organisms, worms, and then flies and mice, eventually humans. And we saw that it activated that enzyme. So resveratrol is one way to activate it. And you can think of it as the accelerator pedal on a car. It revs it up. But there's something else that the sirtuins need to work, and that's NAD. NAD is a really small molecule, little chemical in the body that we need for life. It's used by the body for chemical reactions, 400 different reactions in the body, and without it, you're dead within seconds. You need NAD. The problem that we've seen is that NAD levels decline as you become obese, as you get older, if you don't ever get hungry. And the body not only doesn't make enough of it, it's chewing it up as well. There's an enzyme called CD38 that Eric Verdin over at UCSF showed chews up, he's now at the Buck Institute in California, chews up NAD as you get older. So it's a double whammy. You don't make as much, you chew it up, which is really bad because what we've shown in my lab, and so have others, is that NAD levels are really important for keeping those sirtuin defenses at a youthful level. And you can give a lot of resveratrol, but if you don't have the fuel, you're basically accelerating a car that doesn't have enough gas. So you want to do both, and that's what I do. I take a precursor to NAD called NMN, and the body uses that to make the NAD molecule in one step. And so I know from measuring dozens of human beings that if you take NMN for the time period that I do, I've been taking it for years, but if you take it for about 2 weeks, you'll on average, double your NAD levels in the blood. Okay, that's not public information. That's from clinical trials that are not yet published over the last 2 years. There are other ways to increase NAD levels in someone like me who's getting older. I'm 52 now. You can take NR, which is used to make NMN, which is used to make NAD. And both NMN and NR are sold by companies in the US. NR lacks the phosphate. Phosphate's a small chemical the body needs. You've probably heard of the atom phosphorus. Let's go back one step. How do you make NR? NR gets made from vitamin B3 often. You can also find it in milk and other foods. But sometimes people ask me, why don't you just take vitamin B3 and won't that just force the body to make NAD? And the answer is no, it doesn't work very well. We know this just by doing the experiment. But the reason I think is that NAD is I said it's a small molecule, but relative to vitamin B3, it's big. It's got those phosphates on there. It's got a sugar. It's got the vitamin B attached. So you've got all these components that come together to make this very complicated little molecule called NAD. And when you give NMN, it contains all three components that the body needs to make NAD. If you give NR or just vitamin B3, which is an even smaller molecule, the body has to find these other components from somewhere else. So where do you get phosphate? Well, body needs it for DNA, needs it for bones. So high doses of something that requires additional phosphate makes me a little concerned. And we have compared NMN and NR head-to-head in mouse studies. For instance, NMN, we've shown in a Cell paper a few years ago, makes mice run further. Old mice can run 50% further because they have better blood flow, better energy. NR at the same dose did not do that. In fact, it had no effect.
I see. Dosage-wise, if I were elect to take NMN in supplement form to increase my NAD levels and presumably slow my aging, how much NMN should I take? What's the protocol that you do? And are the various forms that are out there, are some better or some worse?
Well, I'm always happy to tell you what I do and what my father does, my 82-year-old father. We take a gram of NMN every day.
So it's a gram of resveratrol and a gram of NMN.
Right.
Okay, 1,000 milligrams.
Now, another important point, which is I'm not the same as everybody else. I have a different microbiome, age, sex, right? And so I've been measuring myself. And so I know if something's, or I think I know if something's making me better or worse based on measuring 45 different things. So I just want people to be aware that what I do may not perfectly work at all for others. But I have studied, as I said, dozens of people who take NMN at a gram, sometimes 2 grams. And I know by looking at all those people that without any exceptions, that if you do what I do, your NAD levels go up by about 2-fold or more. And so I do that every day, the 1,000 milligrams. Now, people sell it. Now, I never get into brands and all that. First of all, I don't have the time to measure products. I don't know. Though I should say, I do want to say I'm working on a solution for people to know what works and what's real and what isn't. But I'm not there yet. And in the meantime, I would say, if you do want to buy this, let's say you want to buy NMN, look for a company that is well established, that has high levels of quality control. Look for 3 letters, GMP, which is good manufacturing practices. And so that means they make it under a certain level of quality control. You're not going to find iron filings in there, and it probably has the stuff in it that they say it does. That's all I can say right now. I'm working on something that's going to be much more helpful. But overall, make sure it's white, crystalline NMN, and that to me, it tastes like burnt popcorn.
You crack open the capsules and you'll take a little sample to make sure it tastes like burnt popcorn.
Well, when I'm making my capsules, I'll taste it, and I do a lot of quality control on the stuff that I take.
Do you take that gram all at once with the resveratrol, or do you take it spread throughout the day?
It's all in the morning for those things. So if I take metformin, it's NMN and the resveratrol all together, and there's a good reason for that. It's all scientific. I try to be. The levels of NAD go up in the morning in our bodies naturally. Our bodies actually have a cycle of NAD. It's not steady.
It's circadian?
It's circadian. In fact, NAD controls your clock. This was shown by Shin M.I. and colleagues in a nice science paper about a decade ago, that if you disrupt the NAD cycle, which is controlled by the sirtuin gene that we worked on, that is what's telling your body, oh, it's time to eat, it's time to go to sleep. And if you take the NMN late at night, for example, you can disrupt your circadian rhythms.
Interesting.
Conversely, when I travel and I want to reset my clock to the time zone, I will take a boost of NMN in the morning, and I feel great.
Does this protocol for you, does it produce any immediate effects of increased energy, et cetera? You mentioned that one would, if it's right for them, would have to take it for at least 2 weeks to start to see the NAD levels increase. At that point, when NAD levels increase, could one possibly expect an increase in overall energy, focus, et cetera? I realize we're not making promises here, but I'm just wondering whether or not the only measure of whether or not this protocol is working is whether or not you die at age blank or blank plus 20. And of course, once you're dead, you can't really know if you would have lived longer if you'd done something differently, and vice versa.
Sure. Well, there was a study, again, by Shin M.I., my good friend at Washington University in St. Louis, that showed that it improves, remember this, insulin sensitivity, which is a good thing. So, but you can't know your insulin sensitivity unless you're measuring have a glucose monitor on your arm.
Do you have one on right now?
No. No, I used to. I learned a lot.
Yeah, last time I saw you, you had this thing. It looks like a small leech, not a large leech, and it was measuring your blood glucose.
They're very informative because you learn what your body reacts to. And grapes were really bad. Rhonda Patrick agrees with that. But the issue was what? Where were we, Andrew?
The issue is whether or not you can expect any immediate effects on energy, vitality, focus, just even subjectively.
So what do you feel is the question. And anecdotally, because I've been taking this for a long time, if I don't take it, I start to feel 50 years old. It's horrible. I can't think straight. It may be placebo, but who knows? But what we're doing now are very careful clinical trials. We've done the safety for 2 years, and we're now treating elderly patients at Harvard Medical School with some wonderful colleagues. And those people are actually going to be and currently in MRIs, so you can measure the energetics and the NAD levels in their legs as they exercise in real time. And that will tell us if what we see in the mice, this increased endurance, actually works. In the meantime, it's fun to talk about anecdotes. I have a number of athlete friends, some of which have increased lowered their time in marathons, for example. There's a good friend of ours in our circle that is winning marathons at age 50 now. And he attributes that to the protocol that he's on.
Interesting. I haven't started taking NMN, but I'm planning to do that when my next birthday arrives, which is in a couple months. But I do experiments on my sister and have for years. I have a sister who's 3 years older than I am who is very enthusiastic about these protocols. And I'll tell you that after reading your book, I started purchasing for her and giving her an NMN supplement. And she claims, and I believe her, she has a quite sensitive system and she's very tuned into it. She feels far and away better when she takes it as opposed to when she doesn't. And I've done the control experiment of removing her supply and then giving it back to her and this kind of thing. So that's my other laboratory. This is what younger brothers do to older sisters. I have a question about something that if it has no relevance, we can just treat it as a speed bump and then move right on. the artificial sweeteners, these things that, or I should say non-glucose increasing sweetener. So you've got stevia, which is a plant basically, and then you've got sucralose and aspartame and all these things. There is some evidence that I know we're both aware of that have been published in quite reputable journals showing that they can disrupt the gut microbiome in certain cases, in particular saccharin, the one that basically nobody uses anymore. And it's questionable as to whether or not stevia has the same negative effects, et cetera. That's not what this is about. But in terms of the sensation of, or the perception of sweet taste, is that itself a possible detriment to these pro-longevity, forgive me for using the term, the pathways? You know, if I were to drink a Diet Coke during a fast, am I somehow disrupting this? And I'm asking this question because I get asked this question a lot.
Mm-hmm. Well, there may be small effects. I don't think they're worth worrying about. Joe Rogan laughed at me because I was drinking a Diet Coke during the first interview I did with him. I will drink Diet Coke. I've read the scientific literature. And again, it's this 5% thing that I think is blown out of proportion. If I was to put a number on it, I would say if eating a high sugary meal or drinking a sugar-filled soda, what is that, 30 grams of sugar? Let's say that's a 10 out of 10 bad for you. A Diet Coke might be a 1. And if I'm, which am I going to do? I could have a 10 or a 1 or go without in my life. I'll do the 1 on occasion. I try to avoid them because I don't like the 1s as much. But you can't say that sucralose is equivalent to drinking a sugary soda. There's just no comparison. And I think stevia. I do use stevia whenever I can because it's a naturally sourced product, and I haven't seen any good evidence yet that it's bad for you. But I think a lot of this is overblown, and a lot of it's the media trying to give equal weight to stories. As you know, as a scientist, it can be frustrating when something's a 10 and something's a 1 and they're equated.
How do I say this respectfully? I think if science journalists were required to post their credentials alongside their name, then people would take the articles with an additional grain of salt, right? I mean, in other words, that I think that the science media is mainly generated around 2 specific goals. One is to make people very, very afraid, or get people very, very excited. And oftentimes the get people excited part is sponsored content. And I think that's overlooked. In any case, thank you for that. I want to talk about iron and iron load. We were talking earlier about ferritin. And of course, women menstruate. And so their iron needs are greater than men that don't menstruate, or women that don't menstruate. I don't think we can get right down into how much iron somebody needs because it'll vary person to person. But I was surprised to learn that iron is actually going to accelerate the aging process in various contexts.
Well, this is a new finding out of Spain. Manuel Serrano's lab has found that excess iron will increase the number of senescent cells in the body. And senescent cells are these zombie cells that accumulate as you get older, and they sit there and they cause inflammation mainly, and also can cause cancer. And it's found that if you get rid of these cells or never accumulate them, you stay younger. In animals, and there's some really interesting studies out of Mayo Clinic in humans as well. So iron is a pro-senescent metal. And so what I think is that if you're taking excess iron as a supplement, you're probably accelerating your aging process. The other thing that I found really interesting is I've looked at hundreds of thousands of people's metabolism and their blood biomarkers. I was one of the first people inside Tracker as a board member, and I'm still their scientific lead guy. So I can look anonymously at hundreds of thousands of people's blood work. And we also know how fit they are, how old they are. Some of them are marathon runners, some of them are CrossFit. And there's a signature of health that actually is different than your average person. Now, I'm not going to say bad things about MDs because a lot of my best friends are MDs, and I work with them at Harvard Medical School. The issue, though, is that with MD training, there's a scale of what's normal, and if you're out of that normal range, something must be wrong. That's the paradigm that they work under. But first of all, everybody's different, and you want to know their baseline and track people over years to know what's normal for them. And what I find, for example, is people who are really healthy and live the way I do and have a diet that's fairly vegetarian but not strict, still have slightly low hemoglobin levels, slightly low iron, slightly low ferritin, but we have super amounts of energy. We're not anemic, and we're getting along with great in life. But a doctor who just looks at that might say, oh, we need to give you more iron. Right? So what I'm getting at is an example of we need to personalize medicine and look at people over the long run to know what works for them and what's healthy for them, and not just work towards the average human, but work towards what's optimal for human.
I love that answer. You mentioned tracking and tracking over time, and this is a really interesting area that I know you have been focused on for a long time. I've been getting blood work done about every 6 months since I was in college. I like data, and I got interested in supplementation and exercise because it made me feel better, but I also want to know what was going on under the hood. So you get numbers back. You get this hormone, that hormone, this blood glucose measure, et cetera. How do you make sense of the data? I mean, what Inside Tracker is doing aside, how do you personally make sense of the data in ways that might differ from the way that a standard MD might look at one of these charts? Because the standard practice is to say, is it red, yellow, or green, right? Is it basically too high or too low? Is it somewhere close to the margins, or are you okay? Are you in these ranges? Are there any things that you pay attention to that you think are particularly interesting for people to just take note of? I mean, we're not asking you to go against anybody's physician, sure. But what sorts of things should people start to educate themselves about in terms of what these molecules are on their charts if they choose to get them, and what do you look at?
Yeah. Wow, there's a lot there. The first is that you should be tracking things because one measurement isn't enough. These things vary and over time. And if you can have a decade or more of data, it's super informative, as you know. So the physician, interestingly, my physician, let's take him as an example. So he sees me, he says, how are you feeling? I'm feeling great. Okay, see you next year. That's craziness. Anyway, so I say, okay, stop. Let's talk a little bit about...
Let me educate you. That's what David tells his physician. I imagine that the 12-year-old David Sinclair says to his physician, listen, let's have a different discussion. Is that how it works?
It is. He finds me pretty annoying, as does my dentist. But so I say, stop, hang on. I've got this data. I've got the Inside Tracker data. So I pull that up on the screen, and I'm showing him the changes in my cholesterol, in my CRP, which is an inflammatory marker, as you know. And we're going through it, and you can see things change over time, and I've corrected them as they go slightly out of the optimal range for me, which is different than what he would do, of course. But what was funny is that he says, this is great. I love this data, but I'm not allowed to get this because, of course, the insurance companies won't pay for it. So again, you can pay out of pocket. It's not super expensive. I would say if you save a bit of money on a coffee, you can afford this kind of stuff. But the main point is that doctors do like this data. It's just that they're unable to spend the money on every one of their patients to get it.
Is there a code word that someone can use with their physician that will trigger a comprehensive blood test? I keep trying to figure out what's the code that one needs to ask or tell their doctor, like, I'm feeling blank, so that they get a full blood panel.
Well,
do you have to be hemorrhaging from the gut or something?
Well, I usually use the WTH method, which is what the hell. And then he says, okay, we'll do it.
Interesting. Because I think a lot of people out there are thinking, look, I'd love to have blood work repeatedly over time, but that's hard to get for financial reasons, but also a lot of people just don't know how to approach the conversation. And this is one of the things that I hope that we can educate people on, that they deserve to know what's going on inside their body, and that it makes a doctor's visit worthwhile, and that you don't have to feign illness in order to do it.
Right. Yeah, and a lot of people do. So I would say if you can afford these tests, there are an increasing number of companies that offer these tests. Inside Tracker is one of them. And you just do it a couple of times a year at a minimum. And then you can share that with your doctor. If you can't afford that, then I would say to your doctor, here are the main ones that Andrew and David do.
Yeah, blame us. And there's an email that is something like 555, or a phone number rather, it's 555-5555. I think if they have any complaints, they can just call that number. David will pick up on East Coast business hours, and I'll pick up outside of those hours.
But there are some main ones. I would say your blood sugar levels, you want to do your HbA1c, which is your average glucose levels over the month. There's CRP, which I mentioned for inflammation.
Yeah, let's talk about C-reactive protein for a second, because I think it's been shown to be an early marker of macular degeneration, of heart disease, of a variety of different things. CRP is something that we don't hear enough about, I think. Maybe, what do you know about CRP that I don't? I'm guessing a lot. But
it was originally picked up as something that was associated with heart disease in the Framingham study, I believe. It is the best marker for cardiovascular inflammation, and is also, we use it as a predictor of longevity. And its levels go up with mortality. And so this is an association, but there's enough data that I would say if you have high levels of CRP, you need to get your levels down quickly. And the levels usually go up with age and with levels of inflammation. So the ways to get it down would be to switch the diet, eat less, try to eat more vegetables. You'll find it will come down. There are also drugs that can do it. Anti-inflammatories can do it as well. But CRP it's actually HCRP. There's a high sensitive or HSCRP. Your doctor will know. Get one of those readings, because if you've got normal blood sugar levels, your doctor, or fasting blood sugar levels, your doctor might say you're fine. But a lot of people have normal blood sugar but have high CRP, which is just as bad for you long term and can predict a future heart attack.
Along the lines of heart attack, I want your thoughts on cholesterol and serum cholesterol and dietary cholesterol. I cannot for the life of me get my arms around this literature. And even if I ignore all the essentially nonsense that's out there in various social media groups that's saying cholesterol is the worst thing in the world, or cholesterol is not, or dietary cholesterol has nothing to do with serum cholesterol and nothing to do with longevity. I can't seem to sort through the very basic data that essentially ask, is having high levels of LDL going to kill me earlier? Should I be striving to always reduce LDL and increase HDL? Is that a reasonable goal? And if so, is dietary cholesterol the primary determinant of that? And just as a final point about this, I am aware of quite good data that shows that anorexics, people that essentially eat no food unless you force them to, can often have very high LDL. So their dietary cholesterol is essentially zero, and so they're manufacturing a lot of their own. So realize this isn't your primary area of expertise, but you're a smart guy. You think about this kind of stuff a lot. What do you think is going on with the cholesterol literature, and will we ever get to the bottom of this as a scientific and medical community? Because to me, it is rather perplexing.
It is. But you can get through the politics. I know a fair bit about cholesterol because it's in my family history. And I was headed for an early death. My grandmother had a stroke at 30. That's how bad I am in terms of my genetics. So I went on a statin. And I know there's a lot of people who say that statins long-term are bad. It's associated with Alzheimer's disease. I've been taking a statin since I was 29. And that's because I forced my same doctor to give me the statin. The conversation was something like this: you're too young to be on a statin. I said, what, you want me to have a heart attack before you give me something? Or give it to me now. So 29, I've been on a statin. And my cholesterol was way up in beyond 300, which is a massive. Basically, my blood was creamy to look at. So I've now got my cholesterol down to low levels to, what would it be? You can check on my inside tracker. But so my ratio of HDL to LDL, which you want to be less than 5, is now 2. And the LDL is below 100. So it's all good. And I've measured my cardiovascular health with an MRI. I got a movie of my heart beating. I've still got a heart of a 20-year-old. So that's working. I'm willing to forego the risk that the statin is causing problems later because of my family history. But other people, I would say, be aware that statins aren't perfect drugs. There are some interesting new ones. There's one called the PCSK9 inhibitor, which is I think fortnightly, every 2 weeks injection that blocks the release of LDL from the liver. And then that seems to be great for lowering cholesterol, but also has other benefits that might be pro-longevity. And there are some people that I was just talking to who are on the cutting edge of this, and their doctors are trying them on this drug instead of the statin. So you could talk to your doctor about that.
Do you avoid dietary cholesterol for that reason also? Red meat, butter. I mean, I happen to love butter. I love red meat. I realize there's some people who don't. My cholesterol is a little bit high, but I'm working to bring that down a bit, although not by altering my food intake yet. But what do you think is the relationship between dietary cholesterol and serum cholesterol? And what's going on with the liver? Why are anorexics?
Yeah.
Why is their serum cholesterol so high when they're eating nothing?
Yeah. Well, there have been a number of papers over the years that have been ignored. And our friend Peter Attia brought to my attention recently a new study that I think definitively said that dietary cholesterol has almost zero impact on blood cholesterol levels.
Good.
Yeah. So I'm annoyed because I've been avoiding eggs and butter for most of my life, and I didn't have to. So I have eggs.
Plenty of time, or at least in your case.
Yeah. So that's the thing. You can eat these foods that were once banned because it's very difficult to take cholesterol up into the body from the gut, and most of it's being synthesized in the body.
Wow. I'm just pausing there for a second because I think that it's what we've been told, 6 meals a day, eat a lot of grains and fruits and this kind of thing. Avoid cholesterol. I mean, basically everything we learned in the 80s and 90s and early 2000s is getting flipped on its head now. But I think this is a very strong caveat that's important to mention, amino acids, in particular the amino acids that come from animal products, right, seem to have some pro-aging effect on them, right? At least the way that I've heard you describe your diet. Now, I'm somebody who enjoys meat. I like it. But so I'm by no means a vegan at all. But I've heard you say you eat mostly plants, but a little bit of fish or chicken or something of that sort, or eggs, or but is that specifically to avoid excessive amino acid intake, or is it something specific about plants that excites you with respect to? I mean, vegetables are delicious too, but what is it? Is it something great about plants, or is it something bad about? When I think of meat, I guess the biologist in me thinks amino acids, right? I don't think top sirloin, I think amino acid. No, I think top sirloin as I'm eating it, but really what they are amino acids, including leucine.
Yeah. Well, there are two good things about plants, and neither of them is taste for me. I would eat steak all the time if I could. I did when I was a kid. I'm Australian. But plants have two benefits. One is that they're highly nutritious, and they'll give you a lot of the vitamins and nutrients that I need. I don't take a multivitamin. I don't want to have the excess iron in my body. So there's that high density nutrition. So those dark leaves, if it's a spinach salad, great. The second is that there is what's called xenohermetic molecules in plants. That term, xenohermesis, is a term that I came up with my friend Conrad Howitz, which means stressed plants make molecules that benefit your health. I'll break it down. Xeno means between species, and hormesis is the term whatever doesn't kill you makes you stronger and live longer. And the idea is that when plants are stressed out, think of a grapevine that's dried out and they're starting to harvest the grapes, which is typically how it's done. They are full with resveratrol because resveratrol is a plant defense molecule that I think is made to activate those sirtuin genes in a plant. So plants have sirtuins just like we do. But by purifying or at least concentrating in a light-proof bottle and keeping it out of the air, we stabilize this xenohermetic molecule, or it's a cocktail, not just one. There's others in wine. We then ingest those and get the benefits of activating our own defenses because our food was getting stressed out. And by stressed, I don't mean psychologically stressed, I mean biologically stressed. And so I try to eat plants that have gone through a bit of stress. They might be brightly colored, they've had too much sun or got nibbled on by a caterpillar. So you go to places where it's organic or it's fresh, local, and those are the plants that aren't perfect, and they probably have high concentrations of these molecules. And in addition, I also buy the supplements to make sure I'm getting enough of those as well.
Which supplements mimic that?
Well, so resveratrol will, there's another one called quercetin, or quercetin, some people call it, which you find in trace amounts in apples and onions. And we also showed back in 2003 that it activates sirtuins as well. But others have, 20 years later, found that it kills senescent cells or helps kill senescent cells. So it's a double whammy with that molecule.
And are you actively picking out the peaches that look like they were nibbled on by a caterpillar?
No, but I don't worry if they've been banged up a bit.
What's the story with antioxidants? Are they of any value whatsoever? Because the way that you described them at the beginning and what I've heard recently is that they are not all the rage for anti-aging. What are they doing that's useful? Should we be seeking out antioxidants anyway for other cellular health purposes?
Well, yeah, antioxidants are not going to hurt you unless you take mega doses. We do need some oxidants for our immune system. And there's even what's called mitohormesis, which is your mitochondria power packs need to have a little bit of these free radicals to be able to function. So you don't want to overdose on these antioxidants, vitamin C, vitamin E. Don't overdo it.
You don't take a multivitamin, correct?
Right.
I think I'm going to stop after this conversation because I've always just taken one for the kind of insurance purpose, which is a stupid purpose. Not actual insurance, but just thinking, I'll top off on my ACBD.
Right. And I'll pee out what I don't need.
Right.
Yeah, sure.
Well, that never bothered me. The whole expensive pee thing never got, that argument never got me because a good vitamin is not that expensive. I just figured better safe than sorry, but it may be that it's detrimental.
Well, it can in the case of iron, as we discussed, and the antioxidants. So when I came into the aging field in the early 1990s, it was all about antioxidants. And we thought that enzymes by the name of catalase and superoxide dismutase were going to be the key to longevity. It turns out that it's largely been a failure, that giving animals and humans antioxidants haven't had the longevity benefits that we dreamed of. And the main reason is that there's a lot more going on than just free radical damage. The epigenome gets disrupted. We've got these proteins misfolding. And so the problem really has been that we didn't realize that you need to turn on the body's natural defenses against that, plus a whole host of other things to get the true benefits. But I'm not going to say it's a problem taking an antioxidant drink. Mm-hmm. Pomegranate juice, for one, is full of good stuff, including xenohermetic molecules. Mm-hmm. But resveratrol is a good case in point, which is when I worked on resveratrol as a longevity molecule, first we showed it in yeast and worms and flies and mice. Before that, it was thought that resveratrol was good for your heart in red wine when you drink red wine because it's an antioxidant. So then we showed that it extended the lifespan of yeast cells through this genetic pathway, the sirtuins. And we then tested whether resveratrol, if we changed one atom to make it not an antioxidant, guess what? It still worked fine. So it wasn't its antioxidant activity that was extending lifespan. It was its ability to turn on the yeast's defenses against aging. Conversely, when we gave the yeast antioxidants, they lived shorter. So yeah, that was the beginning of my transformation into thinking, turn on the body's defenses, don't give it the antioxidants.
This is an opportunity for me to say something that I've been wanting to say for a long time, which is that what's so wonderful about science is that because the goal is mechanism, you can really start to understand, as you just described, what actually mediates a process is very different than what modulates a process. I mean, if a fire alarm goes off in the building right now, it's going to modulate our attention. But that doesn't mean that it controls our attention. It's not mechanistically relevant. And so I think this thing about antioxidants is one of these cases, it sounds like, where it's in the right ballpark, but until one really unveils the mechanism as you have, you can be, one can or in a field can be badly wrong for a very long period of time. It sounds like the sirtuins and really getting down to the guts of the machinery of what causes cells to age is really what it's about. Zooming way out, what are the behavioral tools that one can start to think about in terms of ways to modulate these, basically the way that DNA is being expressed and functioning? I've heard you talk before about hormesis of other sorts, cold exposure. We talked about fasting. We talked about exercise in broad terms, but what about any evidence, if it exists, as to whether or not aerobic training versus weight training, these sorts of things. In other words, what are the sorts of things that people can do to improve the sirtuin pathway? And I realize that there are caveats. We can't go directly from a behavior to sirtuins, but in the general theme, what can people do? What do you do?
Right. Well, we know that aerobic exercise in mice and rats raises their NAD levels, and their levels of SIRT, one of the genes goes up, two actually, number 1 and number 3. What we don't know yet is what type of exercise is optimal to get them to change. We will learn. We're doing work. Now it's revealed that we're doing work with the military in the US to try and understand that kind of thing. And I'll always tell you and the public when I don't know something. I'm not going to extrapolate. But what do? I base my exercise on the scientific literature, which has shown that maintaining muscle mass is very important for a number of reasons. The two main ones are you want to maintain your hormone levels. I'm an older male, losing my testosterone and muscle mass over time. And by exercising, I will maintain that and have. In fact, I probably haven't had a body like this since I was 20. So that's one of the benefits of having this lifestyle.
Sorry to interrupt you. You know, we did an episode on hormones, and there are data in humans that show that there are some males in their 80s and 90s where their testosterone is equivalent to the average of 25 and 30-year-olds. I can get you that information. It is really impressive studies. Unfortunately, they didn't include a lot of information about the lifestyle factors, et cetera. But this idea that testosterone goes down with age, it might be the trend, but it's not necessarily a prerequisite.
Right. I believe in naturally increasing and maintaining these hormone levels. And I've been measuring them for a long time. And I could see, for me, my testosterone levels were going down.
And then you got tenure and they went back up again.
No. I actually became complacent and it was the worst. Actually, my age changed in the wrong direction after that because I was relaxed.
Interesting.
And not worried about the future. But then I got serious and I actually, according to the Inside Tracker algorithm, got my age down from 58 to 31 in a matter of months. So that was a big drop. And I've been getting steadily younger over the last 10 years, according to that measurement, the blood tests.
What about estrogen? Because women are different in the sense that they do, the number of eggs and the ovaries change over time, right? Do you think that they can maintain estrogen levels over longer periods of time using some of these same protocols?
Well, yeah, I get into trouble from a certain university when I talk about this too much.
About estrogen?
Just about fertility and long story. That if I don't want to get too much into the anecdotes, but I'll tell you the science, which is that if you take a mouse and put it on fasting or caloric restriction for up until the point where it should be infertile, so that's about it. At a year of age, a mouse gets infertile, female mouse.
Due to fasting? Or due to simply to aging?
Due to aging.
Okay.
Due to aging. The fasting, it's not an extreme fast. It's just less calories.
Got it.
Then you put them back on a regular food and they become fertile again for many, many months afterwards. So the effect on slowing down aging is also on the reproductive system.
Interesting.
And so that I wouldn't say to any woman, I wouldn't think that they should become super skinny to try and preserve fertility. That's not what I'm saying. But these pathways that we work on, these sirtuins, are known to delay infertility in female animals. Case in point, I'm one of the lead authors on a paper where we used NMN. Remember, this is the gas, the fuel, the petrol for the sirtuins. We gave old mice, one group of mice was 16 months old. Remember, they became infertile at 12. Gave them NMN, and I think it was only 6 weeks later, they had offspring. They became fertile again, which goes against biology, textbook biology, which is that female mammals run out of eggs. Turns out that's not true. You can rejuvenate the female reproductive system and even get them to come out of mousopause, as we call it. So that's a whole new paradigm in biology as well.
That's super interesting. Sorry to interrupt you, but I'm reminded by a set of studies that were done by your former colleagues, because they're no longer there, David Hubel and Torrance and Wiesel, my scientific great-grandparents, won the Nobel Prize for discovering what are called critical periods, this phase of early development when the brain is extremely plastic. And a big part of their work was to show that after a certain point, the critical period shuts down. Essentially, the brain can't change, or not nearly as much. And then people came along later and showed that you could open up these critical periods again, but very briefly, and it takes a very specific stimulus, essentially, high degrees of focus, et cetera. However, there's a well-known phenomenon in this literature where if you take an animal, and to some degree, this is being shown in humans as well, and you let them pass through the critical period, but then you essentially sensory deprive them. You take away experience, you close both eyes. You essentially reopen the critical period. So it seems like, and I couldn't help but mention this, that there's this parallel between what we're talking about here with fertility and neuroplasticity, where yes, there's a timer where certain things are available to the organism early in life, and then they tend to taper off. It's not an open and shut, but they taper off. But then a deprivation can actually reactivate the availability of that process. Forgive me, I just couldn't help but mention it. But to me, both of those things are associated with youth, fertility and neuroplasticity. And so I think that it'd be so interesting. I'd love to collaborate with you on this to explore how neuroplasticity might actually be regulated by these things like the sirtuins.
Right. And the sirtuins do control memory in neurons as well. So what I think is really interesting is that what we're learning from work that you and your colleagues have done, and in my lab as well, is that the body has remarkable powers of healing and recovering from illness and injury. And what we once thought was a one-way street and you just can't repair, you can't get over these diseases, you can reset the system. And the body can really get rejuvenated in ways that in the future we'll wonder, why didn't we work on this earlier? The future of humanity is more like us walking around like Deadpool. We'll probably be cleaner and we won't smell as badly, but Deadpool, if you don't know, can get injured and just recover. It's very hard to injure this guy. And we're going to be the same. There are many species, you cut off the limb grows back.
Salamanders
Yeah. We are now learning how to tap into that system. And in part, what we're doing is reversing the age of those cells and telling them how to read the genes correctly again, reversing the age of that epigenome. And when you do that, the cells, the brain, for instance, the skin, we did the optic nerve.
Let's talk about those results for a second. And then I want to make sure that we return to some of these behavioral protocols. You had this amazing paper at the end of last year, cover article, full article in Nature, showing that essentially a small menu of transcription factors, which control gene expression, et cetera, could essentially reverse the age of neurons in the eye and rescue those cells against damage, essentially allow blind mice to see again and offset degeneration of these retinal cells. Incredible paper, and such a boon to the field. Where does that stand now in terms of human clinical trials? I mean, what are you envisioning in terms of the trajectory of those data from mice into humans someday?
Right. Well, to get to the point immediately, we're going to be testing the treatment on monkeys, just for safety reasons.
Sure.
And then the first patient should be done sometime in 2022, early 2023, and we're going to try to recover blindness.
This involves making an injection of a virus into the eye, right? Right now, there's no way that I am aware of to manipulate these transcription factors through a pill or some other.
That's what we're working on in my lab at Harvard right now. So it will be
pill-based modulation of transcription factors.
Well, yeah, pop a pill and the whole body gets rejuvenated by 20 years. That's what we're aiming for. Now we do it with gene therapy in the eye and other places. So in the eye, yes, it's a single injection. The genes go into the retina and we can turn it on with a drug called doxycycline. And we do that in the mice for 4 to 8 weeks. The eye gets younger. We can measure that because we can measure the clock. And then the vision comes back in those mice. And I don't see any reason why it shouldn't work in people because it's the same structures and mechanisms that are on in the human as well. Now
and it's one injection.
It's one.
I should mention injections into the eye. Obviously, nobody should do this outside of an ophthalmology clinic, and they're definitely by an ophthalmologist. But the injections into the eye are painless if done correctly by the right person. It sounds dreadful, but it's actually, I've seen it done hundreds of times. I've done it thousands of times, and it's not to myself, but to other creatures. And there's a way of doing this so it's completely painless to the person.
Oh, you don't feel it. It's a tiny, tiny needle too. But the great thing about this is that it's a one-time treatment. Those genes go into the back of the eye and stay there forever. And you can just turn them on whenever you want. So what we found is you can turn them on in the mice, they get their vision back, and then you turn it off again. And so far, many months out, the benefit has remained. But if it does decline, we'll just turn it back on and reset the system, rinse and repeat. So one day, what's exciting is that we could potentially do this across the entire body and just take this antibiotic every 5 years and go back time and time again.
In thinking about the body and what's going on under the hood, I'm amazed still that there isn't a simple, affordable technology that would allow me to just look into my body and see whether or not there are any tumors growing anywhere. I mean, it's not that hard to look into the body. I mean, that the technology exists. Why hasn't anybody created an at-home or pseudo-at-home solution like a clinic where you can go and pay $50 or $100 and see if you have any tumors growing in your body?
Yeah, it's still expensive. You can get your doctor to try to get you in. There's some companies that offer blood tests that look at circulating DNA that'll measure it. We're getting there. It's still probably 5 to 10 years away from being really cheap. You can do things like a colon cancer test at home. I think it's $100 and something. You ship off your shit, excuse my language, and they measure it. And they tell you if you've got colon cancer with high probability. I did that during the pandemic because I didn't want to get a colonoscopy.
Is it more accurate or as accurate as a colonoscopy?
I believe it's close to being as accurate. The downside is that during a colonoscopy, they can pinch off the polyps that are looking dangerous, whereas this obviously isn't that. But it's certainly easier to do. And my father, who's Australian, tells me that it's free for Australians. They get this test routinely.
Interesting. I want to return to the topic that I took us away from, so I apologize, which is behavioral protocols. Do you regularly do the cold shower thing, ice baths, cold water swims? Are you into that whole biz?
Well, you do know that I've done it at least once because we did it together.
That's right. Not the same bath, just to be very clear. Same sauna, different ice bath. The idea of Sinclair and Huberman taking an ice bath together is, it might warm some people's hearts, but just to be very clear, same ice bath, different times.
Yeah. Thank you for clarifying.
Yeah.
I don't do them regularly. I do try to sleep cool. I sleep better anyway. I try to dress without a lot of warm clothes. I'm here in a T-shirt. It's middle of summer, but in winter I'll try to wear a T-shirt too.
So you're challenging your system to thermoregulate.
Right. I've got this hypothesis with Ray Cronus. We published what's called the metabolic winter hypothesis, which is a few tens of thousands of years ago, we were either hungry or cold or both, and we rarely experience that now. And so we try to give ourselves the metabolic winter. And part of the problem, I think, with the obesity epidemic is that we're never cold. And when you're cold, you have to burn energy. It may be only slightly, but over the whole night, if you're a little bit cool, you'll actually expend more energy. So I try to do that. But I'm not a big fan of cold showers. The sauna, I don't have access to my gym as much as I did. But I do want to get back into it. I used to do it regularly with my son, and I posted on Instagram once that he could stay in there for 15 minutes and I could only stay in for about 3. Anyway, long story short, I try to compensate with changes in my diet and exercise until I get back into it.
You reminded me of something that I meant to ask earlier, that obesity reduces NAD levels and accelerates aging. How? I mean, okay, so again, this is the scientist in us. You know, so someone's carrying a lot of excess adipose tissue, subcutaneous and visceral fat. But why should that reduce NAD in any ways that are independent of effects on glucose and insulin? Is there something direct about white adipose tissue? And the reason I ask this is not simply to dig into mechanism alone, but I think there are really interesting data now that fat actually gets neural innervation. I mean, it's not just stored fuel. It's stored fuel that's acting as an endocrine organ, essentially. So, why would being fat make people age faster?
Yeah, that's a question that is so obvious, but so few people ask it. That's what makes you a good scientist. And so that we don't know, but I'll give you my best answer, which is that obesity comes along with a lot of problems that include a lot of senescent cells in fat. If you stain old fat for senescent cells, it lights up. Mm-hmm. And when you kill off those cells, at least in mice and maybe in humans, it looks like the fat is less toxic to the body because those senescent cells in their fat are secreting these inflammatory molecules that will accelerate aging, as we now know. You talk about the sirtuins in NAD. So if we just look philosophically at why this would be, the sirtuins only like to come on or get activated when the body is under adversity. And if a cell is surrounded by fat or contains a lot of fat, it's going to think times are good, doesn't need to switch on. So that's the evolutionary argument. Mechanistically, we don't know, but it could have something to do with the response to glucose, which then responds to the sirtuin gene. But that hasn't been worked out very well.
And is there any evidence that leptin, this hormone from fat, can actually interact with the sirtuin pathway?
I don't recall seeing that.
Maybe I could do a sabbatical in your lab, and that'd be a fun one.
Definitely.
Because leptin during development is what triggers the permission for the hypothalamus to enter puberty. Right.
Yeah.
This is why kids that eat a lot when they're young and get overweight will also start to go and undergo puberty more quickly, although they have reproductive issues later.
Well, yeah, we should study the hypothalamus together because the hypothalamus can control the aging of the body.
The most interesting part of the brain.
For sure.
Yeah,
for sure.
Absolutely.
If you turn on the SIRT1 gene, the sirtuin gene that we work on in the hypothalamus, it actually will extend lifespan. Also, it's been shown by Dongsheng Kai at Albert Einstein College of Medicine that if you inhibit inflammation in the hypothalamus in a mouse, it will increase or maintain the expression of what's called GnRH, which is the hormone that he found actually controls longevity in the mouse in part. And so keeping inflammation down in the hypothalamus is sufficient to extend the lifespan of animals. And I reviewed that paper for Nature about 7 years ago. And that was the first demonstration that the hypothalamus is one of the leading regulators of the body's age.
I find this fascinating. GnRH, for those of you that don't know, actually comes from neurons in the hypothalamus that then literally reach down into the pituitary and trigger the release of all the things that control fertility, luteinizing hormone, follicle stimulating hormone, et cetera. It's such a powerful set of neurons, and it's never really been clear what at a behavioral level triggers the release of GnRH. There's all the stories about pheromones and timers in puberty, et cetera, but environmental conditions and dietary conditions and behaviors that can control GnRH release, I think, is an incredible area for exploration. I'd love to do that sabbatical, by the way. I have a couple seemingly random questions, but I can't help but ask because one thing I like to do is forage the internet for practices that at least more than a few people are doing and then wonder whether or not there's any basis for it. You mentioned methylation as a detrimental process, the way it disrupts the epigenome, the CD reader, so to speak. There are people out there who are ingesting methylene blue. And when I was a kid, I used methylene blue to clean my fish tank. And I love fish tanks. I know you're into aquaria also. A different podcast episode, we'll talk about aquaria. But why in the world would people ingest methylene blue? Meaning, is their logic correct? And or is that a dangerous practice? I'm not sure I'd want to ingest methylene blue. Sounds not like a bad thing to do.
It stains your body. You've seen.
Yeah, when we would. Blue. Yeah, there was someone in my lab as a postdoc was using it to study a completely different process related to the blood-brain barrier, and he used to inject it into animals, and they would turn blue. But then again, people ingest colloid silver. They'll put in there's this. Please, people, don't do this, or if you do, just don't tell me because I won't like it. People put it in their eyes, and some people actually stain their skin. They actually become kind of this silver, purple, brown color if they do it excessively. I mean, there's a lot of crazy stuff out there. But what do you think they're thinking with this methylene blue thing, or should we just get them to a good psychiatrist?
I don't know for sure. I think methylene blue was found to extend the lifespan of some lower organism, and that's where it came from. my recollection.
With the emphasis on lower organisms.
Yes, smaller organisms. I think, do you remember, Andrew, does it interrupt or interfere with mitochondrial activity? And
maybe that's why they're doing it.
Yeah, okay. We need to look this up and post it.
Okay.
We'll get to the bottom of this. But those methyls, let's talk about those.
Yeah.
Those methyls have to be placed on the right part of the genome. They get attached to the right genes and the wrong genes. And if you have a lot of methylation, it's going to mess up the epigenome. Smoking will do that, lack of exercise, all that good stuff. So what you actually want to do is you want to measure it and make sure what you're doing with your body is working. How do you know that if you do this or that is actually helping? And so you can test your age. I could take a swab from your mouth and tell you how old you are biologically, and then we could work on trying to bring that down. And actually, there are anecdotes now that people are reversing their age by a decade or more, just by doing some of the things that we've talked about and some other cutting edge stuff that I'm going to write about. But you have to measure stuff. I didn't want to forget to bring that up. I'm measuring stuff all the time. I have blood tests like you. I've got this monitor that's stuck to my chest right now that's measuring myself 1,000 times a second, and I measure my biological age.
What's it measuring 1,000 times a second? A huge host of things?
Yeah. So this little device is stuck here, and it's for 2 weeks. You just recharge it or send it back and get a new one. It's got body temperature, movement, heart rate variability. It's an FDA-approved device. It's not a toy. It's not one of these recreational things. It also listens to my voice. Eventually, it will tell me if I need a psychiatrist or if I'm depressed. It will tell me how I sleep, obviously. But when you put all that data together and it's individualized and anonymized, it can now tell my doctor in real time if I've got a cold that needs an antibiotic or it's just a virus, if I am suffering from COVID-19, or even if I'm going to have a heart attack next week. And so these little devices are going to be with us all the time instead of going to your doctor once a year, which is ludicrous.
I have to ask you about x-rays, because every time I go through the scanner at the airport, I think Sinclair would never do this. And the argument I heard you give about this before was a really excellent one, which is that, it's a low-level amount of radiation going through at the airport, but the argument is always, well, it's just as much as on the plane. And your counter argument, I should say, was, well, then why would I want to do both, right? So when you go to the airport, assuming you're not running late and you have to go through the standard line, what do you say to them? And do you say, I'm David Sinclair? And then they shuttle you to your own line? What do you say? You do say, I don't like this thing. Do you have to give them a reason?
No, you don't. You can say, I don't want this, and they'll get annoyed because it's hard for them to pat you down. But you get a pat down and you're done. As long as you're not in a hurry, it's fine. If you want to pay for the TSA pre in America or the way to get around those scanners, you can do that. So I travel a lot, so it's worth it anyway. But I just go through the metal detector. I don't get scanned.
And the metal detector doesn't have the same problem. And what about x-rays at the dentist?
Well, one x-ray is not going to kill you. 2 is not going to kill you. But I'd
3 will kill you. Yeah. No, I'm just kidding.
I try to limit it because it's cumulative.
Right.
And I went for 6 years without having a dental x-ray. And then my last visit, I just gave up. I was tired of arguing with my dentist. So they gave me one. But they've got lead coats on and they put lead all over your body. That's telling you something right there. And funnily enough, my teeth hadn't changed. Now, you could balance that by saying, well, 1 x-ray, 2 x-rays, 3 x-rays is worth it if I have cavities. And that's true. You want to know what's in there. But doing it regularly, for me, I don't think was worth it because my teeth are in perfect health and have always been. Don't have any cavities. Didn't have braces. They're fine. So stop scanning me. I mean, I know you have to pay for the machine, but, do I have a choice? Yes. So stop pressuring me.
Who shared your sentiments about x-rays and the dentist in general, my apologies to the dentists out there, was the great physicist Richard Feynman. This is a story about him that's not especially well known, but he had very serious concerns, health concerns about x-rays because he understood the physics and he understood enough biology that he was actually quite vocal about his dislike of dental technology and its dangers. And he talked about some of that. People can find that on the internet. if they like. Speaking of people who are like Feynman, who've been engaged in public discourse about science, one of the things that I appreciate about you, in fact, the way that you and I initially came to know one another, is through your public health education efforts. So obviously, we're doing this podcast. You've done the Joe Rogan podcast, Lex Friedman's podcast. Excuse me, Lex. I'm still adjusting that. Lex Friedman podcast, and many other podcasts. You've written an amazing book. What are you thinking these days in terms of what the world needs in terms of education from scientists, education from MDs, education in general as it relates to these things? Because, I think if nothing else, 2020 revealed to us that there's a gap. There's a gap in understanding, and that the scientists too are guilty of not knowing what to do with all the information that's out there on PubMed or elsewhere. I'm just, what are you thinking for yourself and in general? I'd like to just know, what do you think the world needs there? Maybe we can recruit some more public educators.
Yeah. Well, we've gone from a time when you and I were in college and young professors, where the only way to get our voice out to the public was either through a newspaper or a very short radio interview, which for me was extremely frustrating, because particularly the newspapers and my topic every time was twisted into something that was not just embarrassing, but Harvard University used to bring me into the back office and slap my wrist. How did you say such a thing? We're all going to live to 150. I didn't say that. So we're now also in a world where we're overwhelmed with information, and most of it is wrong, and anyone can pretend to be an expert. So we've gone from early days to now the future, and we're experiencing it right now thanks to guys like you, people like you, is that the experts, some experts, a small number who are brilliant and good communicators, are talking directly to the public. This has never been able to be possible until this time right now. So another 5 years from now, and certainly by 10 years, I would hope that there are trusted sources of information of people who can not just communicate the ideas directly, but are able to talk about things that are going on that aren't even published yet, to say, here's what's really going on, and this is what the future looks like. But this is somebody like yourself who's spent their whole life studying a particular topic and knows what they're talking about. And this is also something that I think most people don't know, that we scientists, if we tell a lie, we burst into flames. We absolutely cannot tell something that's untrue. And to the best of our knowledge, we say it as it is, because if we don't, we're beaten up and we're kicked out of the university. So the people who survived to our age, and I'm a little older than you, so I've survived a bit longer.
But a lot younger inside.
No, well, we have to measure you with my swab test.
I probably need a little help, hopefully not too much.
We'll measure that, and we'll work on your eating. But this is really, really important, is that finally people like you are allowed by our universities to talk to the public. I used to do it with a real threat to my survival. People would look at me, oh, he's a salesman, he's promoting this and that. It was seen as a real negative. But finally, I think we're in a world where it's not negative anymore, and the pandemic showed that we needed voices of reason, voices of fact that you could trust. And you can see the popularity of your podcast shows that the public they're desperate for facts that they can trust, because they don't know what to believe anymore.
Well, I am being completely honest when I say this, that, I followed your lead. I saw you on the Joe Rogan podcast and my jaw dropped. I was like, this is amazing. Like this, because he had other good scientists on before, but you're, tenured professor, Harvard Genetics, Department of Genetics. And for those of you who don't know, there's the Harvard and, of course, Harvard Medical School, and they're both excellent, of course. But these are the top tiers of academia, and I certainly understand what it takes to get there and survive there and to thrive there. It's like a game of pinball. You never win. You just get to, if you're doing really well, you get to keep playing. That's the truth in academia. And if you're not, you stop playing, basically. But when I saw you explain what you were doing in a way that was accessible to people, and also talking about possible protocols that they might explore for themselves to see if those were right for them, I was just dazzled and excited, and I made every effort to get in contact with you, and the rest is history. But I think what's really exciting to me these days is because of 2020 and everything that's happened and it continues to happen, there's a thirst for knowledge. There's also this direct to the public route that you mentioned. And I think there's also an openness. I'd love your thoughts on this, but it seems to me that there's an openness from the general public about health practices, that there are actually things that people can do to control their stress level, to control their sleep, to control their cholesterol, if that's what they need to do. Maybe they don't. And to even control their lifespan, which I think is remarkable. And, I know I speak on behalf of so many people when I want to say thank you. You've truly changed the course of my life. I would not be sitting here doing this were it not for your example. And I always say, Sinclair, many people have written books, many academics have written books, as you have. But in terms of doing podcasts and really getting out there with your message in a way that I have to assume raised your cortisol level and heart rate just a little bit, but you did it nonetheless. You were truly first man in, and that deserves a nod, and I have a great debt of gratitude to you for that. So thank you so much.
Oh, thanks, Andrew. You've become a good friend, and I'm super proud of what you've done and I know what you will do.
So in addition to your book and your presence on social media, Instagram and Twitter, and appearances on podcasts, recently I've noticed that you've opened up a sort of an email/website that people can access, to get some information about their own health and rates of aging. Tell us about that, and what's being measured, and what is this test that you've been working on secretly, and now soon not so secretly?
Yeah, well, what I want is a credit score for the body to make it easy for people to follow their health. And there is a number. There's a biological age that you can measure. Unfortunately, the test is many hundreds of dollars right now. But in my lab, we've been able to bring that down a lot. And so I want to democratize this test so that everybody has access to a score for their health that can predict not just their future health and time of death, but to change it. And I'm building a system that will point people in the right direction and give them discounts for certain things that will improve not just their health now, but 10, 20, 30 years into the future. And we can measure that and very cheaply keep measuring it to know that you're on the right track. Because if you don't measure something, you can't optimize it. And so this is the biological age test. We've developed it. It's a simple mouth swab. We're rolling it out. We're building the system right now. And there is a sign-up sheet because a lot of people want to get in line. Go to drsinclair.com. You can get on that, and you'll be one of the first people in the world to get this test and see what we're doing.
Oh, fantastic. Will people be celebrating their biological age birthdays? In other words, if I'm minus, if I could imagine, so I'm 45 right now, soon to be 46, but if I were to be so lucky as to get my biological age to 35 within 12 months, maybe you can help me do that. Do I get to celebrate a negative birthday?
Absolutely. And my plan is that those people who take their age back a year or more, we think we can go back 20 years eventually, they'll get a birthday card from me, and it's a negative birthday card.
I love it. And probably very little actual birthday cake being ingested, but who cares, because you're living that much longer.
Well, it's full of stevia. That'll be fine.
And thank you for talking to us today. I realize I took us down deep into the guts of mechanism and as well talking about global protocols, everything from what one can do and take if they choose that's right for them, to how to think about this whole process that we talk about when we talk about lifespan, as always, incredibly illuminating. Thank you, David.
Thanks, Andrew.
Thank you for joining me for my conversation with Dr. David Sinclair. If you're enjoying and or learning from this podcast, please subscribe to our YouTube channel. In addition, please subscribe on Apple and or Spotify. And on YouTube, you can leave us comments and you can leave us suggestions for future podcast guests that you would like us to feature. In addition, on Apple, you can leave us up to a 5-star review and you can leave us a comment. Please also check out the sponsors mentioned at the beginning of this episode. That's the best way to support this podcast. Also, I teach science and science-related tools on Instagram. It's Huberman Lab on Instagram. I also have a Twitter, which is also Huberman Lab. So be sure to check those out. A lot of the material covers things similar to the podcast, but oftentimes I'll cover unique material not featured at all on the podcast. So that's Huberman Lab on Instagram and on Twitter. In addition, we have a Patreon. It's patreon.com/Andrew Huberman. And there you can support the podcast at any level that you like. Today, and in many other previous episodes of the Huberman Lab podcast, we discuss supplements. While supplements aren't necessary or right for everybody, many people derive tremendous benefit from supplements. For that reason, we've partnered with Thorne, Thorne, because Thorne supplements are the absolute highest quality and the absolute highest precision, meaning what you see listed on the bottle is what's actually in the bottle, which is not the case for many supplement companies out there. Thorne is one of the partners of the Mayo Clinic and all the major sports teams, and so they really are very trusted, very highest quality. If you want to see the supplements that I personally take, you can go to thorne.com/U/Huberman, and there you'll see the supplements that I take. You can get 20% off any of those supplements, and if you navigate deeper into the Thorne site through that portal, you'll also get 20% off any of the other supplements that Thorne makes. So again, it's Thorne, Thorne.com/U/Huberman to get 20% off any of the supplements that Thorne makes. Also take note that the Lifespan podcast featuring Dr. David Sinclair as a host launches Wednesday, January 5th. You can find the first episode here on the Huberman Lab podcast channel. They also have their own independent channel. You can find the link to that channel in the show notes, so please go there, subscribe on YouTube, also on Apple and Spotify. I've seen these episodes. They are phenomenal, and you're going to learn a tremendous amount about aging and how to slow and reverse aging from the world expert himself, Dr. David Sinclair. And last, but certainly not least, thank you for your interest in science.